My name is Arun Gupta. I work for Red Hat. And today we're going to talk all about microservices and containers and how they are correlated with each other. And the goal of this talk is based upon something that I've been building upon for the past few months now. I've taken a monolith, rip it apart into microservices. I'll talk about the concerns, what all kind of issues I faced around. So first of all, I'll start with the introduction of what microservices are. What are the concerns when you're breaking a monolith into a microservice, and how do you handle them, and how our containers fit into that picture? Okay. At Red Hat, I run the developer outreach team, so technical marketing, which is on the product side, and developer outreach, which is on the community side. So I run that team for JBoss middleware. Lots of different ways to talk to me. Twitter, Arun Gupta, or my blog. I'm a compulsive blogger. Got a blog a couple of times a week at least. I don't get a good sleep otherwise. Or arungupta@redhat.com. So lots of different ways to talk to me in that sense. So let's jump right in. If you take a classical monolith application, and take any application, but I'm going to be talking in context of Java EE. In a Java EE land, if you're talking about a monolith application, that's typically a var. That is by the big black boundary outside, the yellow box. You will have a UI, a database, a persistence layer, or a business logic layer, all of those components packaged in that one artifact. If you're building a shopping cart, all the functionality for shopping cart is in that one application. Whether it's a user, order, catalog, they're all bundled up together. Typically, in the UI layer, you will have CSS, HTML pages, persistence typically done through JPA, Hibernate, whatever your favorite ORM technology is. In terms of business logic, again, lots of different options, CDI, EJB, JSF, backing beans, whatever you want to do, REST, lots of different ways. But that's sort of your typical structure. And the app would be talking to a cache and possibly a database layer as well. Now, very well-known design patterns of scaling it. You can horizontally scale the application. Hopefully, it's a stateless application, not a stateful application. And then there are well-known ways on how you can scale such applications. Front-ended by a load balancer, client talks to the load balancer, sticky session, all those drills that we have been doing forever. So nothing new there. Another way to package your application is also as a war file, an ER file. With ER file could have multiple war files. So you can sort of functionally put your components together, like in a war file. This is my user war file. This is my catalog war file. And you can have some shared entities between them as a jar file. But the whole concept being ER can scale horizontally with cache and database layer and the way you want to put it. So what are the advantages of monolith application? We have been building them for many, many years now, typically packaged as a single ER file, all the functionality packaged into that one archive. Okay. What that means is, once that archive is deployed, in some cases it could take longer for the archive to be deployed, but once it's deployed, everything that you need, order, user, shopping cart, all those services are up. You don't worry about it because the archive is deployed, all my REST endpoints, EJBs, JSF, all those pages are available to me. They're a lot simpler to develop as well. Because in an IDE, you can load one boom Maven project, hopefully multi-module Maven project, but all those dependencies are very clearly defined. You can focus on them. Tools are a lot more adept in handling those monolith application. Let's take a look at it. How do we evolve such an application? So the initial development is always fun. But let's say you have deployed version 1. You want to change one part of the functionality. Maybe a user shopping service, user service require a change. You change one component. You package up the entire monolith. Process is typically automated, Maven, CI, all that. But the whole monolith needs to be deployed all over again. It's a monolith. Another component change, maybe a CSS change or a XHTML page change. Maybe you can do some caching at the Apache layer, change the CSS, refresh the app. But in most of the cases, you package up the entire monolith and deploy it all over again. Another change, another deployment of the monolith. Now, if your monolith, God forbid, is in a big war file on a heavyweight, bulky server, it's going to take forever to deploy that. So there are some known disadvantages of that. So what are those? Well, It's much difficult, it's fun to make it, but it's a lot more difficult to deploy and maintain. Because a monolith is built over a period of few years. By the time it goes into production, the team has retired or the team has moved on to something else. Who's going to maintain the code now? Somebody else's problem. So that becomes a nightmare in that sense. Depending upon the size of the WAR file, if you're changing one piece of the functionality, is typically an obstacle to frequent deployments. If you want to deploy the app a lot more frequently, like if you want to do 10, 20, 50 releases a day, if the WAR file deployment itself is going to take a few minutes, you would just hold back. You know what? I'm going to put one chunk together and then do the deployment. The other problem, which typically is not perceived as a problem, but is a problem, is let's say you start with Java EE. So today, you are all gung-ho about Java EE. I'm going to use this technology. Most of the time when I talk to customers, says, oh, you know what, we are stuck with Java EE. We can't use any new technology because that's the corporate standard. And that is true, because if you are stuck to Spring or Java EE, because your monolith is built into using that application, it makes it that much harder to migrate the entire application to a different framework. So if a new cool technology or a new cool kid come on the block, it's that much harder for you to try out that technology and say, you know what, I'm going to be more efficient in my development process. This is a beautiful book called Art of Scalability. It defines 3 levels of scalability, x-axis, y-axis, and z-axis. The x-axis one is the one that we are all familiar with. It's the horizontal duplication or horizontal scaling. You spin up multiple servers front-ended by a load balancer. The z-axis one, again, we are familiar with it, called as database sharding, for example, or geo-sharding. So you can say, for the request coming from EMEA, I'm going to handle to this zone, from North America, this zone, LATAM, this zone, so on and so forth. So those are well known. The interesting one over here is the y-axis scaling. And that's sort of the focus for microservices. Y-axis says you can split a service by its function. So in that sense, microservices, what we define, are basically a functional decomposition of your service. Now, there are lots of definitions that float around, but this is, well, I need to fix the URL at the bottom, but this is Red Hat's definition of microservices. So what we think, this is an architectural approach. It's not, it's more like a way that you build microservices. There is no predefined technology, tools, terminology, but it's the way you build your application, which focuses heavily on functional decomposition of application. So if you have a bigger monolith application, which is a shopping cart application, you will say user, catalog, product. Those are 3 separate components. So I'm going to build them as 3 separate services. There's a functional decomposition. They are all single purpose. So it follows the solid principle, the S of the solid principle, which is single responsibility principle. So they do one thing, and they do one thing really well. A key component of microservices, again, which is typically the hardest one, is aligning your teams. Typically when you have a team, it's building the full monolith. There are separate UI team, database team, persistence team, so on. With microservices, the idea is you will have a full cross-functional team. That it's a small 2-pizza team, likely fed by 2 pizza boxes. But then that small team would have the UI knowledge, the persistence knowledge, the business knowledge, the DevOps knowledge, the whole of things. So that's the fully cross-functional team in that sense. Other important aspect to recognize is, one of the questions typically people ask is, should I start with microservice architecture to begin with? Or should I start with monolith, let it evolve, and it becomes bulky enough, then I'm going to refactor it to microservice. So I'm going to touch that point again, because I think that's a very sensitive and important point to understand. And the reason that this revolution of microservices is driven by the fact of digital business today. Think about 10 years ago, how many times you would say, oh, I want my application to be accessible on a mobile phone or a tablet or a variety of devices. That's a given today. If you don't have it, you're going to lose it. 80% of the digital business is heavily run by devices. So in order to meet the velocity, the agility, the speed of digital business, on how many devices you need to cater and how rapidly you need to evolve, sort of in a continuous beta stage, that's the need for microservices. So let's touch upon each of those components and see how they're relevant. Now, I don't build everything with microservices, but when I do build it with microservices. So I think that's a wrong philosophy to have. Don't do that. Because the idea is, with microservices, there's a lot of upfront investment required. You are doing a functional decomposition. One of the typical comments is more about pushing the complexity from your monolith to microservices, but there's a lot of no-ops or outer architecture, as Forrester calls it. Those are required in order to have your microservices be fully functional. So make sure you really make a conscious decision. Think twice, think thrice about why you really want to go with the microservice architecture. It's not a free lunch. There are a lot of extra resources that you need to add on to make sure your microservice architecture is going to be functional. So let's take a classic example. Once again, I'm going to go back to my shopping cart example. UI, business logic, persistence. Let's say you have 3 different teams, and your end goal is really to have order, shipping, and catalog services. So your UI team will contribute the UI for all 3 services. Similarly, your persistence team will contribute to all 3 services and business logic as well. That's where Melvin's or Conway's law come into picture. It says your application is going to closely mimic on how your organization is structured. So guess what? If your organization is UI, persistence, and business logic, you're going to find out that, your application is actually looking like that. That the UI is going to look consistent, but it may not be talking very well to the persistence or to the business logic. So this is, in my opinion, the hardest part of doing microservices. Every time I talk to customers or developers who are dealing with microservices, it says the technology part is OK, but changing our organizational alignment is the hardest part, really. Because you have to have that fully cross-functional team where UI, persistence, business logic, everything is kind of into one team. So once again, highlighting that part, if you want to build order, catalog, and shipping services, that means your teams need to be reorganized per those microservices. And if you are going to a different project, then of course, the team needs to realign as well. One of the key aspects that I talked about microservices is how they're really good for one thing and only one thing. So for example, if it's an order service, it's only going to deal with order. And what I mean by that is, it will know how to do get, put, post, delete, and order, and that's it. Everything else needs to be an aggregate service or a composite service or something like that, which is going to use that service. But that order service knows everything and anything that needs to be done for that order entity, so to say. Each service is an explicitly published interface. I can literally walk into Fry's or Radio Shack or any of the electronic stores and says, hey, here is my Bose QC35, and I want a USB cable. I want an optical output cable or optical fiber cable. Why? Because this is a well-defined interface. I can go to any radio store, put the cable in, and I know it's going to work out of the box. Same thing. With a microservice, it's very important that you have a user service. It should have a very clearly defined interface that, all right, if you want to get a user, here is a URI. If you want to post a user, here's a JSON payload that I require, or a YAML payload, whatever the payload type is. You need to define those interfaces need to be very clearly and explicitly defined. Each service needs to be independently replaceable and upgradable. Now, this is one of the sample home networks. There's a Wi-Fi at the center. Now, there's a printer. There is a desktop. There is a phone. All sorts of devices connected to it. Now, just the fact that your phone needs to be upgraded doesn't mean that your Wi-Fi needs to come down. All the systems need to shut down. Then you replace the phone, and then you connect everything. Same thing with microservice. So let's say you have a shopping cart with the user, shipping, and catalog, and those 3 different services. Just because your user service needs to be upgraded, other services should not, rather must not, need to come down. So that's a very important aspect of it. And I'll show you different ways on how you can achieve that. So hang in there. I got real code samples. Who's this? Folks know it. Uncle Ben from Spider-Man. And he said, with great power comes great responsibility. One of the very key aspects of microservice is you build it, you run it. That means straight from the conception, when you conceived what the microservices is going to look like, your job is not done until that entire production cycle is done. The job continues till the time the microservices is running live. Until that microservice is retired, your job is on. Some team is responsible for it. It's not necessarily a DevOps team, but your team is responsible for it. And I'll quote several examples of Netflix and how they do it. They do it really well. Another key aspect, if you have those microservices, you're possibly using a PaaS or lots of containers running all around your PaaS. So you have these different services floating around. Let's take an example of Netflix here. Now, on a given day, 35% of traffic in the evening in the US is Netflix. 35% of internet traffic is Netflix. 2 years ago, in a Netflix network, 2 billion calls would come in through devices, partners, all those things, okay? So 2 billion calls come in. Those 2 billion calls then translate to 12 billion calls, close to 12 billion calls on Amazon infrastructure. Netflix is 100% on Amazon. 12 billion calls floating around Amazon infrastructure, something is bound to break, period. So failure in that sense is not a requirement, it's a feature. That, what if I can't reach to a service? What should I do? Should I drop the connection? As a Netflix user, I love the fact that if for some reason I'm watching a HD video, and if there is a lower quality video available, it drops down to that. For some reason, if the network connectivity is low, and then it automatically upgrades, oh, your connectivity is higher, I'm going to go back to a higher quality video. I would prefer that as opposed to saying, oh, video not available, go figure out what you want to do. So I think that sort of a fault tolerance is very important. And in that sense, they have a library. Netflix has a beautiful set of OSS libraries. I would highly recommend taking a look at that. But they have this thing called as a Simian Army. Now, in Netflix, they have this infrastructure running. Simian Army is basically saying, this is also called as a chaos monkey, where they just go and pull a random plug, in their service. Just literally do kill -9 a process and see how that service is going to behave. Because guess what? In the real world, there are some real monkeys that do those things. So I think that's a true way of testing your service. See how it's going to fail over to a lower quality service, or what the end user experience is going to be. Another suggestion, what's this movie from? Apollo 13, excellent. Well, and the reason this code is I think this is a very classical video. Up in the space, a few hundred miles up, they had an issue that their oxygen level was okay, but the carbon dioxide level was growing higher. So one of the things was that the whole crew may not survive. And then they had to come up with a unique idea where they had to take a square peg and jam it into a round hole. And that's what they did. And that's what, what happens if you take a monolithic application. You say, my stack is Java EE, that's it, I'm stuck with it, I'm not going to use anything else. I cannot use anything else, even if I want to. With microservices, because you distribute your application widely, this is user service, all I care about is an explicitly published interface, which is a REST interface with a JSON payload. I'm not stuck to Java EE. I can just change the underlying implementation if Node.js tends to work better for me, or if my team is more suitable to PHP, or Ruby on Rails, or Grails, Scala, Akka, pick it. Pick your choice of the language or the framework that works best for you. Another classic example of that is the database choice. You don't have to use, push everything into a MySQL database because, hey, that's a corporate standard. It's a microservice. If Mongo or Couchbase or Cassandra works for you, use that as long as you continue to honor the SLA and the explicitly published interface. So it really enables polyglot. You don't have to be polyglot, but it truly enables polyglot. Another aspect of microservices, which is very important, is to be 100% automated. Now, this is a snapshot of Wells Fargo Bank. That's my bank. Not my snapshot, but a snapshot. In a given month, there is a gardener, there's a utility bill, there is all sorts of bills that needs to be paid. And I don't even care to look at them. When I know automatic bill payment comes, bank automatically gets the money out and pays it to the guy. That's it. I'm done. I get an email summary, and I'm cool. Well, that's how microservice needs to be. They need to be completely 100% automated. So it's a very essential aspect of microservice that if you are going to the microservice-based architecture, you need to have a crack DevOps team in place, which knows exactly that, okay, this is full automation. And by full, I really mean 100% automation. I've seen people, oh, no, full automation is not possible. full automation is what your goal is. If you want to do a microservice-based architecture, don't even think about less than full automation. It's going to be a nightmare very soon. When you're talking about microservices, you need to talk about the messaging patterns. There is a sync pattern or an async pattern. So in terms of synchronous, we use the REST API. So for example, you can use get, put, post, delete. Those are all synchronous in nature. Now, if you're using JAX-RS, then there are ways to do asynchrony. But most of the standard design patterns are, if you use standard REST, is only synchronous. However, you can use message queues to be asynchronous, for example. And that gives you a scalability to an extent. So you need to think about what is your messaging patterns in that sense, or what is your message exchange pattern, synchronous or asynchronous. Another key part for microservice is that all the intelligence as such stays in the microservice or the endpoint, so to say. And let's say if you're using HTTP as the messaging mechanism or ActiveMQ for that sake, those are completely dumb pipes. Those are truly used for transferring data. There is no logic in them. And that's a stark difference from what we call as SOA, or what we used to call as ESB. Now, there is still a relevance of ESB. I'm not bashing ESB in any sense, but that's a stark difference that you need to be aware of. You're just using pure HTTP or a messaging pipeline to send messages back and forth. The intelligence is in the endpoint itself. So, well, talk about SOA. People kind of coin all sorts of terms for microservices, and I kind of agree to some of those. The original intent of SOA, if you think about it, is service-oriented architecture. Right? But when the vendors got into the picture, they started pushing their ESBs. They start jamming down a multi-billion-dollar bill in your throat. And that becomes messy. Centralized persistence, centralized governance. So there are issues around SOA and the ESBs. But effectively, it really captures the essence of SOA pretty well. Some call it as a hipster SOA, or SOA done right. So I kind of agree with most of those terms. Here's a tweet that I did about a couple of weeks ago on what I see microservices is and how is it different from SOA. So the fact that it got a lot of retweets and favorites kind of gives me faith that, OK, that definition is kind of close at least. Some of the thoughts, these are people who are actually building microservice-based architecture. So Conway's law, of course, is an important aspect, as I talked about. How do you need to change your organizational alignment around microservice? Service discovery is a very important aspect of microservice. Now, you have these microservices running all around the PaaS or cloud or containers, wherever they are. As the service comes up, how does a user service know where is the catalog service if it needs to call? Or how does the web interface know where these services are residing? So that self-service registration and discovery of those services is very, very important. Containers is the preferred way because they're much lightweight, but a lot of folks have been doing immutable VMs for a very long time. So that's also one of the ways people build microservices. So sort of how is it different from SOA or related to SOA in that sense? So now you got your app. You have a monolith. How do you want to start decomposing it into a microservice? Do you take a function and say, this is my microservice, I'm going to expose a REST endpoint to it? Not really. That's not the recommended strategy. So how do we do it? Well, you look at the verb or a use case. Remember, it's a functional decomposition. So you say, my shopping cart is going to have a user, a shopping, or a catalog, or a cart. And those are my nouns, so to say. So you start looking at those services. And I need to get, put, post, delete. And those are going to be my verbs. And I'm going to build my services around that. A very important aspect, as I said earlier, is about a single responsibility principle around microservice. Microservice does one thing and one thing really well. And a very classical example of that is Unix utilities. You say ls, it just does ls. It does a damn good job of that. Really fast, really efficient. You can provide switches and stuff like that. If you need, you can start piping it. Say ls, pipe, grep, something. Grep does one thing really well. It doesn't matter what's coming in, what's going out. But grep does search. Whether you're searching in a directory listing, in a file, or wherever it is, does one thing well. So I think that's how microservices need to be defined, that they do one thing well. They define the explicitly published interface, inbound and outbound, and that's the way they should operate. So we have a microservice. We have a monolith. we want to start migrating it towards a microservice-based architecture. What do we do? Well, as part of an ER file, as I said, Java EE already provides you the functionality where you can have multiple war files, and each war file possibly could be functionally decomposed. So you can say, you know what, hey, this particular war file makes sense. I'm going to take it out as a separate war file, maybe in the same container, like Wildfly. I'm going to deploy it separately. But to that war file, I'm going to give a separate caching and a database layer. That's an important aspect. And then that war file, the service A, could be called by my ER, and I could have that service accessible directly to the client as well, if need be. Now, that's just one of the ways. Then I'm going to talk about some of the microservices design patterns, as we have seen, when we are building application or as our customers are using it. So let's say you have service A, B, and C here, each of them of their own war. It's very important that each microservice, and typically this is, again, the functional team alignment is the biggest obstacle typically I've seen. The second biggest issue that I've seen typically is I have this big monolithic application with a big monolithic database. How do I refactor my database? Because each microservice needs to have its own persistent store. There is no shared data between them. That could be an interim step, but you really need to refactor because that microservice kind of owns that entire functionality or domain. One of the concerns with that is, oh, my database is doing my functional referential or foreign key constraints. How do I do that? Then those basically come up to the application layer in that case. But the aggregate and pattern being, you have service A, B, and C. You can expose into each of those individual services, but you may have an aggregator, which is what is being called by the client in that case. And that is calling those multiple services and aggregating those services together to give a response to the client. So really, you're pulling three multiple services into one. And then aggregator can, of course, scale by itself if you need to. Another similar pattern is a proxy pattern, where, again, individual caching and database layers. Now, caching could be optional, but the idea being if it is there, it is for that service. You will have a proxy, so where the client makes a call to proxy. Proxy can do some data transformation if it needs to, and then pass it on to the appropriate service A, B, or C. And this is one of the ways by which you can do, for example, geo-sharding. Depending upon which zone the service is located in, I'm going to delegate it to that particular zone. And again, proxy can scale by itself. Chain pattern, that's the third pattern that I'm going to talk about. So let's say your client actually calls service A then calls to service B, and then service C. Important part to understand here is when the client calls the load balancer, it goes through service A, B, and C. If your message exchange pattern here is synchronous, client is blocked until that C comes back to B, comes back to A, goes back to all the way to the client. So you don't want to wait the client to wait too long. So make sure your chain or the pipe here is not too long. So this is an important aspect. Now, there are workarounds to that, and I'll talk about that in a second. Another aspect is where you make the request to service A, and based upon some business logic, you may have two different pipes, for example, or two different branches. So you can say, I'm going to call service B, and here is service C and D. And that decision, again, could be made within service A, for example. But to the client, on the right side, what you see is an implementation detail on how you're composing it. So you can start abstracting the detail just for your own purpose, but to the client, it won't be visible that these are service B, C, and D. Those could be internal to your application itself. As an interim use case, what you could do is you can say, in this chain, for example, I may like to share the data and the caching layer. So that's a possibility. So important part is, don't go with a preconceived notion. As I said, it's an architectural approach, is a recommendation. So don't say, no, I cannot do this in microservice. But start as an interim step. It's one step at a time that you move ahead. We talked about, so far we have looked at all sort of the synchronous patterns. One of the ways you can do is asynchrony. I don't know why the proxy box is hanging out there. But here, you call service A, there is B, C, and D, and they're all writing to a queue and consuming from a queue. So instead of doing that chain pattern where you're doing A, B, and C, calling one by one synchronous. Here, they're all being asynchronous. So at least you can return a response back to the client. And when the message queue has been processed, then you can send another message to the client, response to the client, that, OK, so-and-so thing is being done. Oh my God, if somebody's counting the number of microservices word I have said this time. So let's see, what are the advantages of microservices in that case? Because microservices are very domain-driven, DDD is a basic fundamental of microservices. Because they are domain-driven design, the code tends to be focused on that particular domain, so user domain. It tends to be much smaller, much cleaner, hopefully. So they are much easier to develop, understand, and maintain in that sense. Because end of the day, each microservice, for example, have an explicitly published interface. You care about only that explicitly published interface. The underlying implementation does not matter. I don't really care about it. You can implement today in Java EE. Today you are deploying on Wildfly. Tomorrow you go on JBoss EAP. You go on WebLogic. It doesn't matter to me. You just honor the interface and the SLA to me. Because microservice is a much smaller scope, so hopefully a much smaller WAR file, so it will start a lot more rapidly, and it's basically a big enabler of CI/CD, where you can do a lot more frequent deployments with a microservice-based architecture. Local change can be easily deployed. Each service, once we have done the y-axis splitting, functional decomposition, each service by itself can easily expand on x-axis and z-axis. So like horizontal scaling and the geo-sharding scaling can happen. We saw some of the design patterns for that earlier. It also helps you improve some of the fault isolation, because this is a service that is being invoked, so this is the cause of error. Then you can have a much higher chance of digging into the source code and identifying which is the REST endpoint that was basically causing the issue over there. And another key aspect of this, which we touched upon earlier, is it really eliminates a long-term commitment to a technology stack. All you care about is the REST endpoint. All you care about is what is the published interface, inbound and outbound payload. What is the underlying stack? It's up to you. So the team changes for some reason. You can of course, change the underlying implementation as well. And it gives you, it's a true enabler of polyglot as well. So this is an important aspect to understand. Now, when you start with a monolith, and I love this article where it talks about if you can't build a well-structured monolith, what makes you think microservices are the answer? You need to understand, if your monolith is a distributed ball of mud, your microservice is going to be a bag of dirt. So it's not going to be easy. You need to make sure that your monolith is following the well-designed patterns, is doing that separation of concerns, is following those. I was talking to a customer, and they say, oh, we have a monolith application. And the monolith application, it's a small website, but it's one JSP, and everything is in one JSP. So, whoa, that's a monolith. That's a classical monolith. How do you refactor that into a microservice? So make sure your monolith itself is following well-designed patterns. If it is not, refactoring is not going to be easy at all. So read this article. I highly recommend it because it does talk about what are the design patterns you need to follow to build a nice monolith. Then the refactoring is going to be a lot easier. So what I'm going to do is I built a simple monolith application. Again, I've been talking about shopping cart, for example. Now, the way my monolith application looks like is this is a WAR file. And the black boundary indicates that around the yellow box. It has got web pages, which are my XHTML pages. So user, catalog, and order pages are there. There are some common files like CSS and JavaScript files that are part of the web pages itself. Then I got lots of classes in there, one for each component, like user, catalog, and order. And similarly, I got configuration files, similarly common files over there. Those are all packaged in a WAR file, and then they have their own database. So let me show you my monolith architecture to begin with. Let me increase my font size for a second. So I'm using NetBeans here, of course. This is my web pages here. So cart.xhtml, catalog item.xhtml, all the web pages are in that one directory. Here are my source packages. If I look at my source packages, it's org, Java E7, Wildfly samples, Everest, and then there is this cart, catalog, checkout, user. All those packages in there. In that each package, I have the required functionality that is available. The good thing about this is, because this is all in one monolith, I don't need to expose any REST endpoints. I just publish the XHTML page. If I need any EJB to be called by another component, so let's say in terms of a checkout, you need to talk to the user and catalog. You just inject the bean, and then you get the job done. Now, that's an advantage of a monolith. That's how the monoliths are designed. So let's see, what did I do in terms of splitting this into a microservice. Now, that's my microservice-enabled architecture of this monolith. So effectively, what I did is I converted that into 4 war files. And if you look at the war file here, so this is a user, order, catalog, and a shopping cart UI. There are these 4 war files. They're all running in their separate containers. They're all, user, order, and catalog have their own database. A new component that gets introduced over here is service registry. And why that is important is because as user, order, and catalog service are coming up, they register themselves through a service registry. There are lots of different ways by which we can do service registry. So typical ways are, say, Zookeeper. That's a lot of people are using that. Console, that's another something similar to Zookeeper. etcd is another example how you can do service registry. Kubernetes, which is the Google framework, provides a wonderful mechanism, and that's what we use in OpenShift as well for service registry and discovery. And I have some of those samples that I'm going to show in the code as well. But the idea being, user, order, and catalog service, as they come alive, they register themselves to the service registry. And there could be multiple instances of catalog, for example. So what you do is when you register yourself, say, here is a logical name, and here are multiple URIs associated with it. And now something goes up, something goes down. The other services that care about it, then they talk to the logical name, say, give me an instance of the service, and then I'm going to interact with that. These are all stateless services, so it really doesn't matter in that sense. Now, there is a shopping cart UI at the top. That is where all the services are composed together. And that UI basically discovers all the services from service registry. Say, oh, you know what? I know this is there is a user, order, and catalog service. I'm going to pull those services together. I'm going to do the get, put, post, delete, whatever needs to be done. So it's purely talking to those microservices. So from the service registry, it gets the URL. It only cares about the URL, wherever the URL is going to be deployed. And then from that URL, it knows what the payload is going to look like. So it makes a get, put, post, delete to do the real job over there. Now, the order is in the center because it might be talking to user and catalog as well, in which case it not only registers itself, but it discovers as well. So it says, for example, the order service is going to discover from service registry the user and catalog service. So if in case it needs to call to do some data validation or some database updates and things like that. So let me show you the code for the split up microservice here. So here is my shopping cart microservice. It's a multi-Maven module. So as you can see, there is a catalog, user, order, and Everest web. I have a separate module called as services, which is where I define how the service registration and discovery needs to happen. It's a different abstraction layer. I'll go that in a second. Then JSF also, or JSF 2.2 actually in Java E7, introduced this concept of a resource contract library that allows you to provide a consistent look and feel across your multiple applications. So what I did is, from that monolith, I extracted my JSF templates, CSS, and JavaScripts, and I put them into the contracts library here. There's just a jar file here. So if I open up contracts, there are no source files. All I have is just meta-inf contracts directory, and I have some CSS and XML files and XHTML files. That defines what my template is going to look like. So leverage that feature of JSF 2.2 to provide a consistent look and feel across your multiple applications in the Java EE LAN. Let's look at my services project here. Now in services, if I look at, say, here, so, well, first of all, look at services package itself, okay? Actually, registration package here. So this is my service registration. When I'm registering a service, all I need to say is string name and string URI. And similarly, I unregister the service that way. And if I'm discovering, all I want to care about is giving a logical name to the service. Okay, on this, discover the service. So that's my service registration. And here is once you have discovered the service, then you may want to say, okay, get me the user. You want to have an abstraction on top of that as well, which says, get me the user service, get me the catalog service, get me the order service. Because there might be multiple ways by which services could be registered or discovered. And that's what I'm showing here. So for example, if you look at the services package here, well, let's look at one of the ways. So for example, here's a simple implementation. Okay, this is a fixed service registry. Now, in this case, fixed service registry is a case where everything is deployed locally. So I'm saying, oh, all my services are local in the same Wildfly container. So if you look at line 27, essentially everything is localhost :8080, catalog resources catalog, user user, order order. So they're all deployed in the same container. It's a fixed URL. It's a simple, easy to reproduce demo environment. It just works. Okay, so that's one way by which you can register and unregister and discover the service. I'm just statically putting those names in a concurrent hash map. Let's look at a different implementation of it. So, well, look at the discovery part of it. In the discovery part of it, all I'm saying is, oh, these are the services that I want to return. So give me the web target. This is which is the JAX-RS concept, and how I want to invoke the service. So give me the web target so that I can invoke the service directly. So you just query the URI, and you create a web target, and you give it to the service that needs to call something. So that's simple implementation here. If I show you a Zookeeper implementation of that, now Apache Zookeeper is a project which was designed effectively for storing configuration data. You can't. The idea is not to store multi-megabytes of data, configuration data, but you can have a name value, and the value could be a few kilobytes. And that's how it's being used. It's a fully distributed configuration system. So one of the ways it has cropped up recently is where people are saying, oh, I'm going to take a logical name of the service, and the configuration data is going to be all the associated URIs to that service effectively. So what I'm doing here is I'm going to fire up a Zookeeper Docker container. So I don't need to run Zookeeper locally. I just say, here's a Docker container, run it. It's going to run up a Docker container. Now, Zookeeper API by themselves are a lot harder to use. So on top of Zookeeper, there is something called as Curator that was started by Netflix, as a matter of fact, and then donated to Apache. So what I'm using here is the Curator framework which sits on top of Zookeeper for the service registry and the discovery part of it. So here I figure out, zookeeper.properties defines my host and the port for Zookeeper. I take the Curator from the Curator framework. I start it. This happens in my constructor over here. Then the registry is straightforward. In that, all I say is, tell me if the node, in terms of Zookeeper, all you create is a bunch of nodes. It's sort of a tree. So you create nodes, and then you create children, and then you create nodes, and then you create children. So when you say register effectively, you give it a name and a URI, and I check, does the node exist, if the parent nodes exist. If it not, I create it, and then I create a ephemeral and a sequential node on it. And that's the Zookeeper terminology. So I would dig into it. But effectively, you create a node, and to that node, you add the znode path. You say, OK, this is the URI. For that URI, this URI is going to be stored at this path. So that's the register part of it. And unregister is pretty straightforward. You just delete it from the map where you're storing all that mapping. Discovery, again, so URI to znode path is stored locally in this class over here. It's a stateful class. But the discover service, it uses a Curator framework. Say, oh, this is the name. So I'm going to construct the path again. Then I'm going to get the path what is the corresponding node for it, and delete it. So that's a simple implementation of Zookeeper service registry. In terms of discovery, that's again pretty straightforward. So all I'm saying is, OK, I got all of these user service. So I got the discover service, so user, and return the web target. And something that we have done here is I've defined 3 different qualifiers. So for example, I've defined a Zookeeper CDI qualifier. When you're injecting a service, all you need to say is, oh, I'm injecting a Zookeeper service or a fixed service. Now, something else that I would like to mention here is Ivar Grimstad. He's a wonderful Java EE community member. He built something called as a Snoop. Now, Snoop is a mechanism, is basically a WAR file that can be deployed in a container. It's also available as a Docker image. You fire up Snoop, and that's purely built using Java EE components. All he's using is JPA, JAX-RS, CDI, and stuff like that. So you fire up the Snoop container, and then you can start putting annotation in your REST endpoint. So for example, you can say on a REST endpoint, enable Snoop and enable Snoop client. And it's written as a CDI extension. Once you integrate the CDI extension, the REST endpoint automatically registers. It queries if a Snoop server is running, and then it registers with the Snoop server. So there are lots of different ways by which you can play around with it. So for example, here, instead of using Zookeeper services, if I were to use a Snoop service, then I will just use this annotation, or say Snoop services, and then it's going to start querying where my Snoop server is running, and it's going to register my services over there, and the discovery is going to happen as well. Now, in terms of the catalog service, for example, here's my catalog service. This is something I was playing right before the talk itself. But for now, what I have is a eagerly startup EJB singleton, so that as soon as the app is up, I know the URL where the app is going to be deployed, and I can fire it up, and it registers and unregisters. I mean, in post-construct and pre-destroy, it registers the service and unregisters the service. So that's the registration and unregistration part. But in the this is my Everest web, which is sort of the front end of the application. So this is where I say, oh, I'm going to inject a service discovery, which is using Zookeeper. And here I'm going to say services.getCatalogService, and I'm going to post a request to that. So all you have done is you have abstracted your service discovery using a couple of interfaces, and all the implementation is underlying. Today is Zookeeper. Tomorrow it could be console or Snoop or HCD. It doesn't really matter to me in that sense. So all this code, by the way, is available on my GitHub repo. Let's see if I'm connected here. So this is available on my GitHub repo, arun-gupta/microservices. The slides are available there as well. I've changed the slides slightly, so I'm going to update them right after the talk. But the key part being, if you look at the code here, so here is my monolith Everest, which is sort of the monolith code. And here is the microservice code, where catalog, contracts, Everest, all the services are very clearly defined. So by all means, take a look at it. The complete instructions are available. You can look at this service discovery document. Here it talks about how do you fire up your Zookeeper container and what needs to be done for that. If you go down, it also talks about Snoop. How do you fire up the Snoop container, and how do you register with that? So all those things are very relevant in that sense. So that's sort of my live example. And this is a metrics that I created when I converted that monolith to a microservice architecture. What really happened? Well, I had one archive in case of a monolith. Here I have 5 different archives, which we just looked at. There were 8 web pages. One of the things that I sort of cheated in the first version is I still have all the web pages in a separate application. But eventually what I want to do is I want to take those web pages, and I'm going to start putting them into the corresponding microservice itself, so that then the microservice can truly evolve by itself. User interface, whatever it is, they can truly evolve by themselves. The number of configuration files, of course, increased a lot more, because each microservice needs to have a persistence, web XML, and all those things. The number of classes, of course, increased. We had the additional service registration discovery classes. And the archive size, this is a very trivial, very hello world kind of application. But in the case of Monolith, it was 24 kilobyte. It got up to about 52 kilobytes aggregated size. Some of the concerns that you need to be aware of when you're doing your microservice-based architecture is, if you're putting the UI as part of the microservice itself, then when you are composing your main application, are you really going back to the portlets model in that sense? That, OK, the user interface I need to pull in and show as part of the web interface. So you need to be aware of that. I need to play with that myself. How would the server-side HTML generation work, specifically if you're using a pure JavaScript kind of a front end? So those are some of the concerns you need to be aware of it. So similarly, one service, one UI. Now, is REST services are the only thing that you want to expose? How would that work, for example, with asynchrony, when you have to push the data to a message queue and so on and so forth? Another important aspect for microservices where you need to think about is two-phase commit going to work? In microservice, specifically, they could be running on distributed clouds, hybrid clouds all around the world. How would you do two-phase commit in that sense? In microservice world, typically people talk more about compensating transactions as opposed to a two-phase commit. So some of the things you need to be aware of. But the last thing I'm going to show here is, I know it flashes time up. As the first thing, what I got is I got the application running in Wildfly container. That's the easiest thing to do to begin with. So if I look at it here, I have this Wildfly Maven plugin. All I say is Maven install, and boom, it creates all the WAR files, deploy them in the container. Zookeeper is running. It registers the service, discovers the service. All those things work out of the box. The next thing that I'm working on right now, I've created a Docker profile. Where it's going to do is it's going to start looking at each of those WAR files. And it has an assembly descriptor where it says exactly how to construct a Docker image for it. So I'm saying, oh, this is my shopping cart user. So take from the user directory, take my WAR file. From that WAR file, construct a Docker image, and use jboss/wildfly as the base image. And then take that WAR file, put it into the Docker container, make a Docker image of it, and run that Docker container. So that full life cycle is possible from within the pom.xml itself. And that's sort of the next thing that I'm looking at it. So one thing that I would highly recommend is if you go to the microservices project here, I would love to get contributions. I file a lot of issues in terms of how I would like to do this. Dockerize a service. I want implementations like take user, shopping, all those different services, have different implementations of it. It's just a REST endpoint and a payload. So you can say, hey, I want to contribute a Node.js implementation of it. I want to contribute a Scala implementation of it. So by all means, whatever your domain expertise is, contribute those implementations, because this project is only going to be as good as the number of people who commit to it. So some of the things. So I'm also looking at, for example, how to use Wildfly Swarm, which is how we create a fat jar using Wildfly, and how can I take a look at that. Vertex, for instance, so lots of different things. Kubernetes, and how do I use Kubernetes for service discovery? So lots of issues that are filed over here. So I would say take a look at it, give feedback, and the project is only going to be as relevant as the feedback that you give it. Well, I think I'm way out of time already, but a lot more I can talk about it. So feel free to catch me anywhere in the hallway. Thank you so much.